All right, so whenever you see the directions factor completely, that's kind of a hint that you're probably going to be doing multiple steps, because completely is implying don't stop, work it all the way out until like there's no more factoring to be done. So that's where our flow chart is going to come in handy. Start here, go here, keep going until you finish, okay? So factor completely is kind of giving us a hint. There's going to be more than one thing to do. So at the very beginning of your flow chart, it says GCF. So the very first thing we want to recognize is the GCF. Okay, so the GCF here is an 8. Okay, so if I pull out an 8, and if I divide both of those by an 8, I'll get x cubed in the first part, and then plus 8 in the second part, okay? But I'm not done factoring, okay? What I do next, I've done my GCF. Now I say, okay, I have a binomial left right here, okay? Or I even started with a binomial. So I've got a binomial. So if you go over to the binomial part of your flow chart, we've got the first pattern, and now we've just talked about 2 more patterns with cubes. So since this is a cube, this is going to be one of our cubed patterns, so we want to follow that cubed rule. Well, this cubed pattern is, let me grab a green marker maybe. Okay, it's on your sheet, but I can't see it. So the cubed pattern, remember, is a plus b, because it's a plus, and then a squared, oh, excuse me, that should be minus a times b plus b squared, okay? So this binomial, we need to factor it out into these two. Okay, so the 8 is going to be a part of the answer, but we're going to focus in here in order to get this last part, okay? So, A, we need to figure out A is what? And B is what? Okay. All right, so the way we get it is we cube root it. So, and we're asking ourselves, what to the third power gives you x to the third power? So A is the same thing as x. Oh, let me do the right color. Because instead of a cubed, it just says x cubed. But the 8, again, is kind of like what we did with the 8 before. We need it in terms of cubed. So 8 is what cubed? So 8 is the same thing as 8 is what cubed? Well, that's the same thing as 2 cubed. So since I put this in terms of cubed, that means that b is that 2, it's that base. All right, or you could cube root it. And when you cube root that 8, you get a 2. And so that's the 2 that you're going to use. All right, now we're just going to put it into the formula. So we have 8 from the very, very, very beginning, that GCF. So 8 is already out front. Now we're just going to deal with the binomial. So a plus b. So in this case, that's x plus 2. And then the next part is a squared, so that's the same thing as x squared. A times b, so x times 2 is 2x. And then b squared is the same thing as 2 squared, and 2 squared is 4. And then since the plus is here, that means the minus has to go in the trinomial. Remember, the binomial matches the original one that we're trying to factor, so that means that the minus must go in the trinomial part, okay? So that's more practice of that, and then that's the example of our layering. GCF, then what next? Then what next? And we keep going, okay? All right, so now factor by grouping. I already mentioned that factor by grouping is actually something that we've already done. Okay, factor by grouping is actually using our box. So let's just review our box one more time. So I'm going to say, don't worry about this. Let's just put that. There's 4 terms. Since there's not a GCF, okay, there's no GCF in here, we can just turn straight to our box. And let me make sure that I'm not off the page. Nope, we're good. Okay, so x cubed goes in the first box. Negative 2x squared goes in the second. Negative 9x goes in the third, and 18 goes in the last. So then remember, we group them up. We just look at them in pairs by rows and columns. So the GCF of these two is x squared, and the GCF of those two is a 9. Don't divide them, but do GCF. The GCF of these two is an x, and the GCF of those two is a 2, it looks like. So then I can always check myself. X squared times x is x to the third. 2 times x squared is 2x squared. I want it to be a negative 2x squared, so I'm going to make that a minus 2 so that the signs match. Okay? X times 9 gives us 9x, but we want a negative 9x, so I'm going to change that to a minus 9 so that it'll make it negative. And then that's okay, because a negative 2 times a negative 9 still work out to a positive 18. Okay? So far we have factored it by that grouping, or by the box, to x, let's say x minus 2, and then x squared minus 9. But if you notice, there is another line here. And if you notice over here, it says factor by grouping, or box. Okay? The distributive property we didn't really talk about, so don't worry about that. Okay? But it does say difference of two squares. That is one of the patterns we already talked about. Okay, I've got a binomial here and I've got a binomial here. But this binomial is actually one of the patterns that we have on our flow chart, because it's got a squared. So if you see a squared or a cubed, you want to say, okay, maybe it falls under one of those patterns. Okay, so we just rewrite this one. And then this one can break down one more time, because it does fall into those binomials where we can say, well, what times what gives us x squared? That's x times x. And then we can ask ourselves, well, what times what gives us 9? Well, that's 3 times 3. Remember, the fronts have to match and the backs have to match. And then to get a negative 9, it's a positive 3 and a negative 3. So we've practiced that individually, but now it's built into these layers of all the factoring that we're sifting through, okay? So we are going to have that a little bit more on the last page, and then we are done with it. So let's just push through and do it 2 more times, I think, maybe 3 more times, okay? And then we'll practice it in class as well. Okay, so let's see. The only thing that's kind of weird to me is that they didn't mention a GCF, and in this problem there actually is a GCF. It is a 4, okay? And the whole reason why we do that is because if you can make your numbers smaller, you've made your life so much easier, okay? So there is actually a GCF. Always look for GCF first. And in this case, it's a 4. So I'm going to divide both of those by 4, and I'm going to squeeze that GCF in the front. They forgot about it, but actually that should be a 4. So, well, I know what 16 divided by 4 is, but 256 divided by 4. Okay. Oh, actually, will it be even larger? There's an even larger one, 64, 16. But it's not something squared, so we'll keep it at 4. Okay, so 16x to the 4th divided by 4 is 4x to the 4th. And then 256 divided by 4 is 64. Oh, so actually, we're going to make this way easier. So you could divide that again. So the GCF isn't 4. The GCF is actually 16. And that's going to make this so much easier. Okay, so again, if you can do that GCF, you're going to make things so much easier on yourself. So 16 divided by 16 cancels out. So that's actually just x to the 4th minus 256 divided by that 16 is 16. So that has actually made it a lot easier because it's so much easier to do these patterns than those large numbers, okay? So 16 is a part of that answer. I'm going to squeeze it in here. That should be 16 times something. And then I am going to write it here and here as well, because that's going to be a part of our final answer. Now, these can both square root, okay? Even though it's a fourth power, that fourth power actually means something squared. And what it means is x squared. If you take x squared and you square it, you get x to the fourth. So that means that I'm squaring this, and then 16 is just 4 squared, okay? Or what you could do, and again, I guess I don't really do kind of this last line. What I do is I ask myself, okay, what times what gives me x to the fourth? Well, that would be x squared times x squared. X squared times x squared gives me x to the fourth. They match, so that's good. And then, what times what gives me 16? Well, that's 4 and 4. 4 times 4 gives me 16, and then it's plus and minus, okay? Now I realize why they have another line. Because when you look at these two binomials, one of them is a pattern again. Okay, so 16 is a part of our answer. X squared plus 4 is a part of our answer. But this one breaks down again. It is squared, and you can square root both of those. Or, what times what gives you x squared? That's x times x. What times what gives you 4? That's 2 times 2. And then it's a positive and a negative. So we actually did that binomial rule twice. After we did GCF, we broke this down to the binomial, what times what and what times what. And then we did it again with another one. Well, now nothing else factors, okay? That doesn't factor because it doesn't have a minus. Those don't have x squared, so that's as low as they'll go. And then the GCF is up front. Okay? All right, this one is just our box. Okay, first thing they already told us is the GCF is 3y to the third. So divide everything by that 3y to the third. Okay, and we get y to the fourth. Here we get minus 5y squared. And here we get plus 6. Now, this is just kind of a funny way of doing our x. Okay, so in order to do our x, now that we've divided out our GCF, our leading number our leading term right here does not have a number, so I can just jump straight to the basic box where I say what multiplies to 6 and what adds to negative 5. Okay, 2 times 3 multiply to 6, but they add to positive 5, so that's negative 2 and negative 3. So those numbers are the ones that are going to go into my parentheses. So far we have 3y to the third, and I know that in the back it should be minus 2 and minus 3. The only thing tricky about this one is that instead of just being y and y, we actually are just going to say it's y squared and y squared, because y squared times y squared gives us y to that fourth, okay? Now, I'm not going to show you a ton of like fourth powers and all that, but just in case, you just split it in half. Y squared times y squared gives you y to the fourth. So just cut that y to the fourth in half, okay? Now, neither one of those are patterns because you can't square root them. You can't say the same thing gives you 2 when you multiply them, or the same thing gives you 3 when you multiply them. So those are actually done, okay? All right, let's see. Let me see the time. Okay, this last one, actually both of these are going to be quicker than the two that I just talked through. So we'll be able to go through these last two pretty easily. I won't say very much because I'll set you up for it. Okay, it says factor completely, so we want to start with the GCF and then go from there. This one has 4 terms, So, and we've already practiced that the 4 terms means our box. So, let's just set up our box and practice that. So let me put mine in, you put yours in, and you check yourself. Alright, so that's what I got so far. Those check. That checks. Alright, I pulled out a negative 25 because I noticed there were 2 negatives right there. So far, this is what I have. But when I look carefully, I realize this x squared minus 25, that's a pattern. What times what gives me x squared, and then what times what gives me 25. We can break that down. That's our difference of perfect squares is what it's called. So really, I can take it one step further and say that this is, actually let me just write it right here, x plus 2, and then x times x gives me x squared, 5 times 5 gives me 25, one's positive and one's negative. So this, after I did the box, this binomial breaks it down one more time. Okay? So you got to start recognizing those patterns so that you can break it down as far as it will go. Okay? All right, this one, there's no GCF. There's nothing leading, and it's a trinomial, 1, 2, 3. So I'm just going to use my x, 45 and negative 14. Let's see, that will break down to 9 and 5, and they're both negative because we want a negative 14. So, but be careful, it's x to the 4th. So when I have an x to the 4th, that really means x squared minus 9 and x squared minus 5, because x squared times x squared gives you x to the 4th. And then those are the 2 numbers that we found right there. But then when we look carefully, okay, they're both binomials. Do I have any type of factoring in that binomial? Well, yeah, x squared minus 9, x times x gives you x squared, and 9 is 3 times 3, so plus and minus. Now, it doesn't work for the 5 because you can't get the same thing. Remember, whenever you break down into patterns, it has to be the same in the front and the same in the back. So these are both x's and those are both 3's. You can't do that with 5. If you were to multiply to 5, they'd be 2 different numbers, and that doesn't follow the pattern. So that is that one. Okay? So we're going to practice this a bunch, but this is factoring. This is why we have our flow chart, so that we can organize and go from one thing to the next thing to the next thing until we're done. Okay?